As much as I like to do integrals, I also like to do factorings. And even though they are just algebra questions, but of course, they can still be very, very interesting. As you can see, these two factoring questions, they look so similar, right? It's just that the powers right here are different and everything else are the same. And let me tell you guys this, only one of this is factorable and the other one is impossible. But which one is which? Why don't you guys pause the video and try them out first? Alright, as I mentioned earlier, only one of this is doable, the other one is not, right? So which one is the one that's not factorable? That one or this one? This one. Well, I'll show you.
We know if you want to get x squared, that is kind of trinomial, we must have parentheses with x and x, right? And of course, we're using real numbers, and of course, we're using rational numbers only. X times x will give me x squared, and now, how can we break down 9? 3 times 3 will give me 9, but then 3 plus 3 would then give me 5. 1 times 9 will give me 9, but then 1 plus 9 is 10. It's not 5, right? And those were the only possible combinations, and none of them worked. In fact, no matter what we do, it's not possible to do this, right? So this right here is the one that's not factorable. And we have to know this so that we don't spend any more time on this factoring question. It's not factorable, that's the answer.
How is this one so different than this? Even though the powers are different, but then we do have the 9 right here and the 5 right here. The combinations are still pretty much the same, right? But trust me, it is factorable. But now we just have to think about how can we do that? Let's attempt it, yeah? This is the trinomial, so let's see, I'm going to open 2 parentheses. And to get x to the 4th power, let me have x squared here and x squared here, right? X squared times x squared, of course, that's the x to the 4th power. But now, how can we get past the 9? Plus 3, sure. When you multiply them, we get 9. But then, we cannot end up with the plus 5x squared in the middle. If I have the plus 1, plus 9, that's going to be plus 10x squared in the middle, so it's not going to work, right? Let me just put down plus 3 here and plus 3 here, okay? Let me just convince you guys. If you really want to put this down, it won't work, because when you multiply it out, you get x to the 4th power. This and that is 3x squared, plus another 3x squared, that's plus 6x squared, and then this and that, when you multiply that, you get plus 9, right? So it's not the same as the original. But then, this is the very crucial step. Because just think about this. Wouldn't it be nice if this was the original question that we're working on? If this is the actual question that we have to factor. This right here is so easy, right? Because we just factored it. But then unfortunately, this is not the original question. This is. And now, how can we make the connection between the original, which is the harder one, and this easier version? How can we make the connection? This are the same, the 9 is the same, but then this and that are different. But it's just a small difference, right? And now, let me show you guys how to do this. Let me write this down again. X to the 4th power plus 5x squared plus 9. And this right here is just like my scratch work, okay, my thought process. Well, I'm going to put this down as equal. I know I have no hope to factor this out, right? But I do have hope to factor this out because it's just that. So this right here is what I have in my red box, okay? We know that for sure. Let me put this down. X to the 4th power plus 6x squared plus 9. Well, this and that, of course, they are not equal yet. But we can certainly make these two equal to each other. How? This is plus 6x squared. As long as I minus an x squared at the end. Look at this. 6x squared minus x squared. We get back to the original 5x squared, right? What good does this do? We can try to do this by grouping now. Let me show you. Look at the first 3 right here. And the reason I group the first three is because I can factor that right here. And then I will group the last term right here by itself like this. And now, this right here, we can factor it. And the cool thing about this is that it is a perfect square. It's x plus 3, or x squared plus 3, and then square, right? So let me just put this down, and we know the inside is the x squared plus 3, and then we have this square. And then for this one right here, it's minus, and I can look at this as x to the second power. And look at that. This becomes what? Difference of two squares, right? So this is your a, this is your b. A squared minus b squared is what? A minus b times a plus b. So I'm going to put this down for you guys. I'm going to write this down as a, which is this, x squared plus 3, and then we minus the b, which is x, and then we multiply by a, which is x squared plus 3, and then we add it with b, which is x, like that. And look at that. We just factor the heck out of that. Look at that.
But as usual, you see the inside parentheses here. This is not in the right order that we like, so at the very end, let me put them down. X squared goes first, of course, and then minus x in the middle, and then plus 3 at the end, times this right here is x squared plus x, and then plus 3 at the end.
Look at that. Who says algebra is not fun?